Okay, we're going to use a CRO to measure the peak voltage and the frequency of an AC supply. What we're using here is we're using a lab pack. The school lab pack, I've got it set to 6 volts. It says 6 volts on it, so you would expect that's what we would get out of it. That 6 volts though is the effective value. It would be equivalent to a 6 volt DC supply, a 6 volt battery. So we call it 6 volts AC. But when we have a look at it on a CRO, and we have a look at the peak voltage, then let's try and see if we can measure that. The two important things we want to measure then are the horizontal and the vertical on the CRO trace. So the horizontal control is the time base, or the time per division. What it actually tells us is the number of seconds that the spot takes to cover each division horizontally on the CRO. In this case, it's set to 5 milliseconds per division. So the spot takes 5 milliseconds to cross each division, or each centimetre on the screen. The other important control is the vertical control, which is called the volts per division vertically. And in this case it's set to 5 volts in here. 5 volts per division vertically, so each centimetre or each division vertically will be 5 volts. Now let's see if we can see the trace. Okay, what I'm going to try and do is I'm going to try and count the number of centimetres up that it is to a peak. In this case it's about 1.5 boxes to a peak, or down the way to a trough it's about 1.5 divisions to a trough. So 1.5 divisions to either a peak or to a trough, and from our volts per division setting, 5 volts per box, then it appears that we're getting about 7.5 volts. The peak voltage of an AC supply is bigger than the AC quoted value. 6 volts on the lab pack, 7.5 volts peak on the CRO. That's because the effective value, the number stamped on the lab pack, doesn't give us the peak value, it gives us the effective value, the same as an equivalent DC. Okay, how do we measure the frequency of an AC supply using a CRO? Well, we can use the horizontal period of the wave to work out the frequency. The period of the wave is the time for one, and we can find the time for one wave by counting the number of divisions horizontally between one crest and the next. In this case it's 4 divisions, 4 centimetres. 1, 2, 3, 4. 4 centimetres makes one wave, and the time base setting is 5 milliseconds per division. 5 milliseconds per centimetre, or 5 milliseconds per box. So 4 boxes, 5 milliseconds means that one wave is 20 milliseconds. 20 milliseconds for one wave, that's the period, the time for one wave. And then again we can use our knowledge of frequency and period. The frequency is 1 divided by the period, and if our period is 20 milliseconds, that's 0.02, then 1 divided by 0.02 is 50 Hertz. 50 Hertz, the frequency of mains electricity in the UK.